Welcome back everyone. This is the second video or tutorial where we will be covering part 2 of completing a civil drawing. In this tutorial, I'll be focusing on calculating area and perimeter and then completing the civil drawing by drawing the sectional elevation. Let's go. The next important thing in civil drawings is calculation of area and perimeter. Let's begin with area. I'm going to take a piece of sheet here again and just do this freehand for explaining purposes. So we know that the formula for area is length times breadth, where one of the sides of the wall will be our length and the other one will be our breadth. So hypothetically, I'm going to make one side 6,000. I'm going to make another side 8,000. So let's now apply this formula to calculate our area. The first thing that you want to do is write the actual formula. So A equals L times B. It will give you marks. Then do not use the number 6,000 as it is. Convert it. Okay. Don't use 8,000 as it is because it will give you problems. So that number of 6,000 is millimeters. That number of 8,000 is a measurement in millimeters. Let's convert it to meters. So 6,000 will be converted to meters. And how we do that is that we take the number and we divide that by 1,000. So 6,000 divided by 1,000 will give us 6. So instead of writing 6,000 on paper, I'm going to write 6 multiplied by 8. That will help me a lot. So when I calculate that, it will give me a number or an answer of 48. Then I have to present my answer correctly, which is with its unit squared. So meters squared is a very important part of getting all the marks for this particular question. So again, ensure that you use the correct measurements, convert them from millimeters into meters, and then calculate. Let me just show you what would happen if you used the big numbers as they are. Look at that. And many of you will not write that number of 48 million correctly. You'll forget a zero somewhere and lose a mark for no reason. So convert your numbers down from millimeters to meters. So typically 1,000 millimeters is 1 meter. 10,000 millimeters is 10 meters. 100,000 millimeters will be 100 meters. So you want to show a smaller number because it's easier to work with them. So everything that's in between, right, will make your life easier. So something like 10,400, right? If you convert that, that's basically 10.4. So you take the number 10,400 and divide it by 1,000 and you have a smaller number to work with, 10.4 meters. I also want to show you a typical idea of how to work with areas. So if you find buildings that have L shapes or some other unique shapes, what you want to do, or the trick here, is just to create blocks and then calculate the area of those blocks using the measurements. So as you can see in the image here, I'm taking the L and the B, I'm multiplying them. So length times breadth of this block. I've looked at this L-shaped building, divided into 2 blocks, and then I know that I have room 1 and room 2. Then calculate the area of each separately. Then add them together to get a total. Look at how I'm going to do it as well for the third image as well. I've got a unique shape here for my building. What I'm going to begin to do first of all is then divide it into 3 equal parts. Then take note of each side with length times breadth. So divide each block, then multiply the length times breadth together of those measurements, and then add them to get a total. And don't forget, your answer must be in squared meters. So whatever unit of measurement you use, squared. Let's do perimeter. Perimeter is to calculate the distance around your building. So that means you have to take note of each turn of your building and add each distance to get a total. So it's one side plus another side. There I'm labeling on my drawing to indicate the side. So each side will be taken into consideration and then I will add them together. So I'm ending up here with about 8 sides in total for this drawing. Then I'll use a formula, and again write down the formula when you have or when you are answering the question in your question papers. Write down that formula. There will be perimeter equals length plus breadth. And the answer here is not squared, it's only meters. Now I want to add the sectional elevation of our drawing, and that must be according to the cutting plane that's provided. So firstly, draw the cutting plane and copy it as it is. You'll see that the triangle is on the line or on that cutting plane and it's labeled. Then you need to add or you need to use your scale to draw it correctly. Now, typically, sectional elevations are at a scale of 1:20. So you look at your elevation, your incomplete sectional elevation drawing, and divide each measurement by 20, and then begin drawing. I'm going to speed through this part because I believe again that the emphasis is more on how you are using your instruments to draw each part. I'll complete the rest of this drawing off camera. Now that I'm done drawing my actual sectional elevation, it's important to now place hatch lines that indicate the different parts of the section. That is the foundation, the concrete slab, the earth, the compact hardcore. Look at how I'm going to be doing those freehand, and you should rather apply the same principles. Again, pay attention to how I'm drawing neatly and I'm drawing correctly. Thank you so much for watching this part 2 of how to approach your civil drawing. I think that we've covered the fundamental and most important things, or rather, some of the things that you will definitely find in a civil drawing. So, if you have any questions, please leave them in the comment section and I will get back to you and answer you. For now, if you liked the video, please like and subscribe, and then click that notification button so that you can get new videos as and when they come out. This is Manier's page. I'll see you later.